Hey, welcome back. Let's take a look at the homework that accompanies Lesson 8 and our practice problems. We're going to use some of the same strategies that we used as we did the lesson, but we're also going to review the work that we did before. Before you get started, come back and take a look at your lesson summary and remember what we did. We talked about 180-degree rotations of line segments as well as figures. But line segments specifically have several possibilities. Something to know is that a line segment pretty much fills up or fits in with any shape that we're going to be translating, rotating, or reflecting. And so a 180-degree rotation is very reasonable to just talk about a line segment. First off, the line segment will copy back to itself if the center of rotation is the midpoint. Again, the midpoint, we can remember, is that this is the middle of the segment. We also know that if the image of the segment overlaps with the segment or lies on the same line, it could land on itself, but not necessarily right in the middle like it does right here. The center of rotation is a point that's on the segment. But if the line doesn't, or if the segment doesn't land back onto itself, if it doesn't map itself, it sits somewhere off on the side, 180-degree rotations are always parallel to the original image. What we're going to do is we're going to keep this close just in case if we have any questions. As we go through this, what we're looking at first is we see that we're going to rotate segment CD 180 degrees around midpoint D. Well, as I look at this looks an awful lot like what we did in class, so I'd refer back to this piece. And one of the first things we did is we just verified that we had the same slopes with these, or the same ratio of change over time. But this was on a piece of grid paper. Now we don't actually have that luxury here. So what we're going to do is we are going to use the strategy of just kind of watching and seeing if we're there, but we're going to use the things that we learned from this one to recognize what a 180-degree rotation looks like when we're rotating points that are on the line, points that are at midpoint, and a center rotation that's off of the line. So keep this handy so you can refer back to it. First off, segment C to D is going to be rotated 180 degrees around point D. So what I'm going to go ahead and do is rotate 180 degrees around point D. That's about 90 degrees. This looks like it's about 180 degrees for a straight line, since there's no coordinate plane underneath of it to indicate whether we're right or wrong. We have one option we could use to help us out, and that's to pick up a straight edge and set that on there and say, how did I do? And when I put that on there, I think that looks pretty good. So I'm going to go ahead and I'll hover over my point right here. This point right here becomes point C prime. I'm going to use my straight edge right here to make sure that I kept that right where it's supposed to be. Looks like I moved just a little bit, but I'll go ahead and mark that there, and this is C prime. We're going to go ahead and do the same thing again, but this time we're going to rotate around center E 180 degrees. Last time what we saw when we rotated off of the center of rotate, or off of the point, we did point E right here, we found out that the image went off of its original, and then in our summary we recognized that when it's not there, we're going to have parallel lines. So when I look at this and I rotate, how will I know where 180 degrees is? Well, I rotate until I see a parallel relationship. How can I tell if it's parallel? Well, I can go and I could measure to see if it's exactly there. But since this isn't on a coordinate plane, I'm going to cut you some slack. Make sure that it looks parallel. Clearly this is not parallel, and this is not parallel. But if I can get really close, and if I can see your work being very, very close, I'm going to be happy with that. So I see a point right here. I'm going to use a reference point for that. Here in a second is between O and D. So I'm going to start on this point, and I'm going to go ahead and move my paper, put a point there. I remember that the other one was approximately here. So I'm going to go ahead and connect my dots, but I need to remember to label it, and I want you to see what happens under the labeling. This point right here was D prime, and this one is C prime. Now, how can I be certain that I actually got the rotation of 180 degrees? I'm going to show you after this next rotation. This one says a rotation around center M, which is the midpoint. So let's go ahead and rotate that center M around the midpoint, 180 degrees. Remember, when the midpoint is the piece that we're using, we know that that line is going to rotate 180 degrees, and it's just going to map right back to itself, just snapping back right to there. So what we would see under that rotation is C prime here and D prime here. M maintains its same position. We could call that one M prime, just like we could have called this one D prime. But here's the final piece that I want to look at. How do I know for certain that this is 180 degrees and that point E is definitely the center of rotation? Well, I'm going to put point M in the middle of this, that midpoint right there. And then what I want to do is I want to take my ruler and I'm going to match up a line from each of the corresponding points. So C to C prime, we're going to draw a line. We're going to draw a line from M to M prime, from M to M prime, and then from D to D prime. And now if I was really, really good at this, I see that my line is just a tiny bit off, but I can see that there's an intersection of all three of those segments that match up corresponding points right to one point. This is a good indicator that I have a nice 180 degree rotation. As we look at the homework for the next problem, I see this one that says draw these three rotations of triangle ABC. I'm going to rotate triangle ABC clockwise 90 degrees. Then I'm going to rotate triangle ABC 180 degrees and 270 degrees. And that just sounds super familiar, almost like I've done that before. Refer back to this part of the lesson, and that should help you with your homework. The next piece talks about each graph. So each graph on mine, it's on the next page, shows two polygons A, B, C, D, and A prime, B prime, C prime, D prime. In each case, describe a sequence of transformation that maps the original to its image. So, first thing that we want to do is we just want to double check. They're telling us that there is a rigid transformation that's here. So we're going to talk about a sequence of transformations that maps this figure to this figure. The very first thing that I see when I look at this one is I actually look at two pieces of a heart. So I know that I need to get this piece of heart to this piece of heart to make it whole, and then I can figure out from there what I'm going to do. What I would suggest, again, this is one of those things where you can do this a couple different ways. I'm going to show you one way. Feel free to use it or discover another way. But in the end, it needs to look exactly like this one. Very first thing I think of is translating quadrilateral ABCD along a vector. I'm going to say from point D to D prime. And then, oh look, I've mended that heart. The last thing I see is that there needs to be a reflection. And when I say that there's going to be a reflection, I must have a line of reflection. And so the line of reflection I'm going to use is the line that contains segment D prime C prime, or that contains segment DC. And then when I fold that over across that line, I see that the images match perfectly together. So again, with this one, I chose to use a translation from D to D prime, followed by a reflection across DC. There's other ways to do this. You could reflect from the beginning right here and then translate. But as far as using rotation, it really doesn't seem like it's necessary for this one. Item B, when I draw this one, I want to check to see what's it going to take. Obviously, there's a translation that's going to have to take place. So I'm going to go ahead and slide this over something and match up a couple points. We're going to go ahead and match up D to D prime just because it's close there. And I'm going to go ahead and rotate around that point, and we'll see if everything lines up where it's supposed to. And if it does, that's really cool. That will tell me that there's no reflection. So in this case, the question comes down to what did I actually do? Well, I performed a translation from D to D prime, and then I did a rotation clockwise. But how many degrees did I actually turn it? That's a good question. Well, here's something to think about when you look through the tracing paper. Here's segment D prime or DC right here, and it's going to end up on this segment right here, DC. How many degrees do you see? Pause the video for a second, look at this angle, and how many degrees do you see from here to here? And then you can use that information when you write your description. The final information that we're working on, Lynn says that she can map polygon A to polygon B using only reflections. Do you agree with Lynn? Explain your reasoning. Well, my first thought is, well, maybe I can just reflect it straight across a line right in between the two of them. Yeah, that's a good thought. Why don't you give it a try? See what happens with that. If not, try a couple other ones. Give it a good go. Don't forget that there's a lot of options for reflection. You can reflect diagonally, such as this. And I think I just gave it away that that's not actually going to fit, so we know that one's not going to work. But you can also reflect across a horizontal line. You can also reflect across a vertical line. Keep those in mind when you go ahead and work with this. Give your best descriptions. Make sure you tell me which figure you're going to move, how you're going to move it, whether it's translate, rotate, or reflect, and then the appropriate descriptions that go with each one of those. Make sure that that's the end of the homework. So we're looking at the last page there. Make sure that whatever you do, you never give up. You're doing great. Thanks for coming back for more, and see you next time.